Hello, hi everyone. Good evening and welcome to the session. If I'm audible, just let me know in the comment section. And is my screen visible? I'm waiting for a minute or two. Just let me know in the chat section whether I'm audible and visible as well. For a minute or two, just let me know in the chat section whether I'm audible. So let's wait for another 5 minutes so that everyone can join. So let's wait for 2 to 3 minutes only. Just let me know in the chat section whether I am audible. Class session will start. Yes, Raval. Okay, so yep, I'm audible. So should I start the session or should I wait for another 2 to 3 minutes? Hi, Abhijit. Okay, I'm audible, right? So let's start the session, okay? So today is the time for object detection, okay? So the topics for the day are, so we'll be going through what is object detection, applications of object detection, and why object detection is very important in current industrial scenario as well. And then we'll be proceeding towards industrial use cases. And then we will be jumping to object detection using deep learning, like how the object detection is done using deep learning, and I will just tell you the complete intuition and how the object detection algorithm actually works. So on the top right, you can see that we have a pic of boats and image, boats of and beach and all that kind of thing. And I think it's a beach side. Yeah, it's a beach side. And there's a plane, and then we perform object detection. And after performing object detection, we get these like different bounding boxes are drawn on different objects. Okay, so here the plane is enclosed in green box, and the boats and all the types of boats are enclosed in blue, and the people are enclosed in red. And then we will be coming towards hands-on object detection using image AI. So image AI is a popular library which is used for object detection. Okay, so let's start the session. So basically, what is object detection? Okay, so object detection is the process of finding real-world object instances like car, bike, TV, flowers, etc., etc., or humans in still images or video. Okay, so object detection forms the base of this image recognition, image localization, and detection of multiple objects within an image. And object detection is commonly used in applications such as image retrieval, security, surveillance, and advanced driver assistance. Nowadays, traffic police is also adopting the system of object detection, as well as they are also performing surveillance across the cities using cameras. So basically, okay, I got this. So yeah, so on the right, you can see that there is a different images. Okay, so basically a single image with different objects in it. Okay, so different objects are these. Let me change the color, and so here are different. Okay, color. Let me change the color to blue, and yeah. So you can see that there's an image of a car, and then there's a dog, and the horse, and the person. Okay, so whenever I give my image as an input to my object detection algorithm, what it will do is it will basically perform object detection and basically return this image. Okay, and in this image the different types of object, that is car, the dog, the horse, and the human are, are enclosed in rectangular boxes along with their prediction probability. So this is the prediction probability in number, and this basically means that our computer vision model is 97% sure that this is a horse. Okay, and you can clearly see that our object detection algorithm misclassified dog as a horse. Okay, so our object detection algorithm basically saying that it's 68% confident, or you can say that it's a 68% the probability that this animal is a horse is 68%. Okay, so yeah, you can see that that's a pretty much low accuracy. And then here's a person with the 0.79, or you can say 80%, or you can say 79% probability. And then there's a car with a probability of 1. Okay, so these are the some quick summary points that object detection algorithm is used for finding real world object like car, bike, TV, flower, human in images or videos. Okay, and object detection forms the basis of image recognition, localization, and multiple object detection. And then it is used in applications such as image retrieval, security, surveillance, and advanced driver assistant systems. Okay, so also one of the most popular use case of object detection is that it is being used in factories for the protection of workers. Okay, so every workers wears a hard hat or a helmet, you can say. Okay, so in factories it has been found that 80% of the death of the factory workers can be avoided if they wear proper safety equipments. Okay, so to monitor those proper safety equipments, these object detection algorithms are used, and this object detection technique is used to basically ensure the safety of workers in the factory. Okay, so yeah, as I told you earlier, that applications of object detection include facial recognition, it includes industrial quality check, self-driving cars, and people counting. Okay, so in countries such as China or US, or the countries which have very dense population, okay, where there are crowds in the public areas. So in the times of COVID, this people counting has become an essential tool for the governments and monitoring services to basically ensure that everyone is following the COVID protocols or not. For example, one of the China's greatest giant, that is Chinese Railways, deployed these people counting object detection algorithms in cameras in basically which are deployed in railway stations. Okay, so as we know that maximum of the public facilities are running at 50% capacity. Okay, so these object detection algorithm count the actual number of people in the railway station and then perform the relevant authorities that yeah, these number of people are actually present in the railway station. And if it's maximum, like it's greater than 50%, if it's greater than the 50%, then the railway station are closed for the next population until and unless the occupancy goes below 50%. Okay, and when the occupancy goes below 50%, only then the next passenger is allowed. Okay, and same thing is also being followed at airports and other public places. Okay, and also as well aware that self-driving cars use extensive deep learning algorithms to perform object detection, object classification, image recognition, and different types of other objects as well. Okay, so now let's go to the next slide. Okay, so why is object detection important? Basically, that why industries are rapidly adapting object detection, and why it is so important in the industry. Okay, so as we all know that object detection is one of the most fundamental problems of computer vision. Okay, so like 80% of the tasks you will be seeing in real world in computer vision are related to object detection, are related to object detection. Okay, and object detection forms the basis of many other computer vision tasks such as instance segmentation, image captioning, and object tracking, and more. So as I told you, in instance segmentation, we have a video or an image of our of basically a real world scenario. For example, a person sitting in a park, and we need to identify the features of the image, for example, where the human is actually present. So the first step to that is object detection. Okay, so the first step is object detection. After the object is detected, then only in instance segmentation or semantic segmentation or image capturing or object tracking tasks are performed. And for example, like specific object detection applications include pedestrian detection in on roads by traffic police, people counting in public areas during the COVID time, waste detection in different corporate sector. We have a face detection algorithm which actually detects your face automatically and marks your attendance. Okay, so this is one of the most popular use cases of face detection as well. And then text detection, and then there's a pose detection, that what is the pose of a human or an animal, etc., etc. And second most important, number plate recognition by traffic police. Okay, so I hope till now that was all theory session and no one has any doubts related to this object detection. Yep, so this is what I was talking about, that what are the actual industrial use cases of object detection. So the most popular use cases include video surveillance, self-driving cars, and in agriculture. Okay, in video surveillance, basically these object detection techniques are used to identify and track multiple instances of a given object in a scene. Basically, there are if in real world scenario that there are multiple, and there are multiple objects present in an actual place. Okay, so to identify and track multiple instances of a given object, for example, there can be different types of car, like one type of car, second type of car, and third type of car. So these are all cars, but the type of cars are different. For example, one can be SUV, second can be your sports car or your racing car, and third can be your family car, like sedan or something like that. So to identify and track multiple instances of a given object, this object detection algorithm is used in video surveillance. And then in self-driving cars, so real-time car detection models is the key to the success of autonomous vehicle system. So that's actually pretty much accurate. Every self-driving car is equipped with object detection algorithms to identify and detect what is going around the car. And these systems, actually these object detection systems, are basically allows to identify, locate, and track objects around the cars, so that the cars can move around through the world safely and efficiently. Now this is the relatively a very new use case in agriculture. Okay, so like agriculture tech is also booming, right? There are multiple startups got funded this year in agriculture, and this is commonly known as agri-tech. Okay, so that means that agriculture technology. So in agriculture, basically, for instance, a custom object detection model could accurately identify and locate potential instance of plant diseases. Okay, so like whenever a plant is suffering from any kind of disease, it's clearly visible on its bark or on its leaves. Okay, so object detection algorithms are being used in agriculture to basically identify those faulty fruits or faulty leaves and allow farmers to detect threats to their crop yield, because this is like basically uh, the plant diseases spread very rapidly. Okay, so if a particular plant has a particular disease, then that it will spread to other crops and will destroy that crops as well. So to avoid these things, object detection algorithm is being used to identify basically diseased objects or plants. Okay, and one of the most fundamental problem lies is this. Okay, like this one, it allows farmers to detect threats to their crop yields and which are not discernible to the naked human eye. So there are multiple types of disease which are not available, which are not visible to naked human eye. So to avoid farmers missing those details and to protect their crops, this technique is being rapidly used in agriculture. So I hope everything is fine till right now, and you all are getting that why object detection is one of the most important part of computer vision, or you can say subfield of computer vision. So let's now come to object detection using deep learning. Okay. So there are two types of object detection. That is one using ML algorithms. Okay. And second is using deep learning algorithms. And basically these types of algorithms are not accurate. Okay. These are not accurate, and these are accurate. Okay. So deep learning algorithms are pretty much accurate and are able to replicate the real world scenario and work pretty well in real world scenario, while as machine learning algorithms are not that much effective in detecting real world objects. Okay. So most of the times, like in today's scenario, deep learning algorithms are being used for object detection tasks. Okay. So basically, how object detection is being performed in these images. Okay, so there are two techniques. Okay, so one is the using algorithms such as RCNN, and second one is SSD. And RCNN basically stands for region convolutional neural networks. Okay, and this stands for single shot detection. So I will tell you why these are known as single shot detection. And basically these contains algorithms such as fast, RCNN, etc., etc. And these contain algorithms such as YOLO, and that basically stands for you only look once algorithm. Okay, so there are two types of algorithms available in deep learning for object detection, and those types of algorithm are first is this RCNN based algorithms. Okay, and then there are second algorithm SSD, that is single shot detection algorithms. And one of the example of RCNN is fast RCNN, or you can these, like there are three types of RCNN. Okay, like one is simple RCNN, then second one is fast RCNN, and third one is faster RCNN. And in single shot detection, you have algorithms such as YOLO. Okay, so what is the difference between RCNN types of network and single shot detection algorithms? Okay, so in RCNN, for example, this is your image. Okay, so this is your image. Now this image will be split into different parts. Okay, and now these parts will be feeded individually. Let me just erase this. Now these parts will be fed individually to basically uh, our CNN algorithms. Okay, and these RCNN algorithms will classify that will give us two things. Okay, so the first thing, it will basically perform object classification. It will perform object classification, and the second task is that this will perform, it will give us coordinates of the bounding box. Okay, coordinates of the bounding box. Okay, so this is the task of basically classification. and this is the task of basically you can say regression. Okay, so let me just change the color. So okay, so okay, so our CNN performs two things, that is classification and it will perform regression. So I am considering that everyone is comfortable with what is classification and what is regression. If you don't know, if you can, you just tell me in the comment section that whether you are familiar with classification or regression or both the things. Okay, just let me know in the chat section. Just let me know in the chat section that whether you are all familiar with classification and regression. If you're not familiar, I'm going to tell you that what classification and regression basically means. Okay, let me just tell you that what classification means. So classification basically means that basically if I give an input to my model and ask this that whether this is a like this is an image of a cat or a dog, then a model will basically classify this image into two things, that is one of the thing, that is dog or cat. Okay, so this is classification, and regression basically means to uh re, output a real number. Okay, output a real continuous number. Okay, so if these are the coordinates of the bounding box, so the coordinates are going to be in rectangular. Okay, the bounding box is in rectangle shape. Okay, so this regression will basically give me four things. It will give me the coordinate, it will give me the four coordinates of the bounding box, that is xy, width and height. So these are the four coordinates. And for example, take this as an example. Okay, so these are the table and chairs. Okay, so if I provide my if I if I if I want to perform object detection using RCNN, so what I will do is I will just divide these image into four parts, and let's come to the first part. Okay, so I'm considering this first part, and okay, I'm considering this first part. Okay, so the first part, you can see that there is a fan. Okay, so my object detection algorithm will classify that it is a fan. It is a fan, plus it will give me the details of the bounding boxes of the fan. Okay, x, y, width and height. Okay, so this is what our model will be going to do. Okay, and this will be performed for every part of the image. Okay, so let us now consider this part, or let us consider this part. Image dot that much detail, so let me just consider this part. Okay, in this part you can clearly see that there is this poster. Okay, so our model will return us that it will classify this image that it contains a poster, as well as it will give me the coordinates of the bounding boxes. Okay, so this is what our CNN algorithms basically does. It will divide the images into different parts. It will run an algorithm to classify the images as well as get the bounding box of the images of bounding box of the object. Okay, so for example, here I got x, y, w, h, and that is some real number, and these. Okay, so this is, you can say, x and y, w and h. Okay, so this is basically the width and this is the height. Okay, so these are the four coordinates. Okay, so you can say that these are the four coordinates of the bounding boxes. Okay, so this is what RCN algorithm does, is divides the image into different parts, and for every image it classifies the object and it gives the detail of the bounding boxes. Just let me know whether. Okay, oh, sorry. Just a second. Okay, so just let me know that whether you got the concept of this RCNN or not. Just let me know. Okay, I'm waiting for a 1 or 2 minutes so that basically get you can get discuss or something like that. Okay, so I think everyone is clear. Yeah, everyone is clear. So let me now just jump to this using YOLO algorithm. So what YOLO algorithm does is, okay, so what YOLO algorithm will do is basically that YOLO will take this image completely. Okay, it will take this image as an input at once, and it will, okay, so this is my YOLO algorithm. It will take image as an input and it will return me an array, okay, an array of different objects. For example, last time we saw that in RCNN divided the image into smaller parts and then performed object classification and bounding box regression basically, and it gave us the object classification and the coordinates of the bounding box, okay, and closing that object, okay. Now in terms of YOLO, this image is not divided into the image is not divided into different regions, okay. So this whole image will be given as an input to YOLO algorithm, and YOLO algorithm, what the algorithm will be doing is that it will be giving every details as once, okay. So let me consider that this image contains a fan and a poster, okay. So YOLO algorithm will give me this thing, okay. It will provide me the object name, okay, for every object, okay. So it will provide me the object name, and then it will provide me the coordinates of the bounding boxes, and again it will classify, or it will basically detect that poster will present in the image, and it will again, okay, and this will go on for every object detected in the image, okay. So this is why YOLO is known as you only look once. It looks at the image for once, and what it does is it basically gives an array where you get the name of the object and then the bounding box which encloses that object, okay. So for example, in my this for example, I have an image, okay, where the 5 objects are present, okay. So that is my first object name, the bounding box of that object, second object, bounding box of the object, third object, bounding box of the object, and so on till 5, okay. So this is why this is known as single shot detection. It basically, it is capable of performing a detection at only in you can say basically in a single step. It is performing all these steps, although it's not a single step. It's known as single shot detection. So basically takes an image, it provides you with the object name and the bounding box enclosing the object. So that is why it is known as single shot detection. Okay. And in RCNN, it basically used to divide the image into different parts, and then for every part, it used to run the RCNN algorithms to get the object class, the object name, and the bounding box of the object. So basically, RCNN are very much slower. Okay. Now let me just use this text box. So RCNN are very slow algorithms, and YOLO is a fast algorithm, is efficiently a way faster than very fast and efficient algorithm. And the reason behind this is that this RCNN uses a lot of computational memory to basically divide the image. It takes much time to divide a particular image and then perform detection on every part of the image. Okay. And then YOLO basically doesn't perform these steps, it eliminates these steps. Okay. And so this is the reason why YOLO is a way faster algorithm than RScaling, basically. Okay. So I will just tell you that I will not go into that much detail of RScaling because that requires a lot of maths. And for now, that is very extensive. But I will tell you that it creates a region proposal. Okay, it creates a region proposal, and on the basis of that region proposal, regions are proposed in an image. Okay, so okay, just so RCNN algorithm basically performs region proposal and then divides the image. So this is the reason why RCNN is very much slower than YOLO. YOLO is a single shot detection. It is capable of performing detection in one shot, and it doesn't need inputs of image in different parts. Okay, it takes input as a input as a single image and then perform object detection. So just let me know that whether the concept of YOLO and RCNN are both clear to you all. And next step is that we will going to Colab and we will be checking out that how actually these things are being performed. Like you can say that we will be basically learning that how we will be using image AI library to perform object detection. Just let me know in the chat section. Clear. Okay. Great. So let's now move forward and come to the interesting part, that is the implementation part. So basically we will be doing this all with image AI library. So image AI library is a Python library that lets programmers and software developers easily integrate state-of-the-art computer vision technologies. And also YOLO is actually a state-of-the-art technology for object detection. And let me just tell you that everywhere where we will be performing object detection in real life, YOLO will be being used. So yep, that's like this is one of the most like this was a revolutionary concept in the field of object detection and computer vision, the introduction of YOLO. There are different versions of YOLO available, YOLO version 1, 2, 3, and 4, and 5. And basically, there's some difference in architecture and some functions. Okay, so we'll be using image AI, and using image AI, we will be performing object detection, and you will be basically seeing that how much easy it's to perform object detection using image AI using just few lines of code. Okay, So let's just go to this. And meanwhile, you all can just open your Colab and let me know in a minute or two that everyone is on Colab. So everyone is on Colab, right? Okay. Yep, everyone is on Colab. So let's now just do some, let me just configure my Zoom so I can. Okay, so just go to your runtime and change the runtime time to GPU. Now, this will allow us to perform some fast computation because this image AI library is built on top of TensorFlow. That is basically a deep learning library. And when we perform computations on GPU, it becomes much faster. Okay, so everyone just go to runtime, and when you go to runtime, just go to this, change runtime type, and use hardware accelerator as GPU. And then come to the first line and you just let me connect. Pip install image AI and dash dash upgrade as well. So this command is going to download and install the most recent version of image AI to your Colab environment. Let me just, yep, the library has been installed, and let me just restart the runtime. Okay, so whenever you download or whenever you install a new library in Colab, you need to restart the runtime so that the library can be configured well. Okay, now let me just, okay, so now we need to download the model which we'll be going to use for object detection. Okay, and I'm providing the link in the, okay, I'm providing the link in the chat section. Just use that link and stay with me on the Colab, or otherwise you will be all missing the point. Okay, so I have provided you with a link in the chat section, and all you need to do is you need to type this wget, and let me just zoom in my screen, wget, and basically just paste the link over here. Okay, so let me just go to this. Okay, just I provided in the chat section, Tanishka, the link, the GitHub link from Akshay Dubey, github.olefin/image AI. Okay, you all haven't got the link. Okay, no issues. Just give me a second. I will be doing it on my Colab and then providing you with the link. Okay, so let me just send the link. I should think that I did you all got the link in the it's in the chat section. It's in the chat section. I have posted it from my private account. You will be all be able to see it. It's github.com olefin Moses image AI releases. Okay, still not. Okay, it's okay. Okay, no issues. Okay, so actually, I'm sharing this notebook with everyone, and you can just run these two commands. Okay, so let me just give me a second. Okay, just give me a second. I'm sending the link. Okay, just give me a minute. Okay, yeah, okay. Sorry, Frederick. Okay, 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 okay. No issues. Just let me check whether from where I can share the link. Okay, I don't see an option over here. Okay, 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 okay. Okay, I will share it in the Discord. Okay, and just give me a second. I'm just sharing the link. Okay, okay, okay. Just let me open my Discord, and I will be sharing the link over there. Mhm. Okay, I think there's no option to share the link. Okay, so don't worry. Okay, so just go to Google, and all you need to type is image AI. Okay, I got something else. Image AI GitHub. Okay, and go to this first link and click on it. Okay, clicked. Now what you need to do is just go to this section and add releases and just press the enter key. And here you will get this ResNet Cocoa Best version 2.1.0.h5. Okay, now you can just copy this link address and go to your this. Okay, go to here and just type in and do wget. So what this is going to do is this is going to download the weights for you. Okay, basically it will download the model which we'll be using for the object detection. So as you can see that the model is being downloaded in the Colab, and you can check it over here that the model has been downloaded. Okay, so I'm just giving you all some 2 to 3 minutes. You just let me know whether you all have downloaded, whether you have got the link or not. Frederick, Pratyush, Parminder, Tanishka, Dinesh, Madhugandha, Ravi. Please let me know in the chat section whether you all got this link or not. Okay, Frederick got the link. Okay. Frederick, just do this. Go to your Colab and write wget, okay? Exclamation mark wget to check whether the model is being downloaded or not. And let me know when the model is downloaded, okay? It's a pretty large, I think 126 MB model, and it should take a while for everyone to download this model. Just let me know whether the model has downloaded or not, has been downloaded or not, okay? If you're not able to download the model, we won't be able to proceed further because this model is actual the backbone of object detection we'll be performing in few lines. Okay, so everyone has downloaded the model, right? Okay, great. So now we need to import some libraries. That is, first we need to import image AI, and we will be importing image AI.detection, and then from image AI.detection we'll be importing object detection module. Okay, now what we need to do is, let me just comment it out for you all. Installing image AI library. Loading the object downloading the object detection model and this RetinaNet. Okay, oh, I think that was RetinaNet. Yeah, this is RetinaNet. ResNet. Okay, this is yeah. So this is a deep learning model which is performing object detection for us. Okay, now we'll be importing libraries and other modules. Okay, now after importing object detection, what we need to do is I'll be just creating a variable in detector which will contain object detection and then I need to tell my model that I need to use the model and the type is RetinaNet. Okay, so the detector over here is basically I'm telling my detector to use RetinaNet model. Okay, and instead of RetinaNet you can see that there were some other options as well. Okay, if I do this again, so you can see that we can use these three models as of now: RetinaNet, Tiny YOLO version 3, and YOLO version 3. Okay, so first I would recommend that I'll be using RetinaNet, and then in your today's assignment, what you need to do is you need to perform the object detection using Tiny YOLO version 3 and YOLO version 3, and the weights are available over here. Okay, so these are the weights. You can basically play with all these weights, that is Resonate 50 ImageNet XFlow 2.0.h5 and Resonate Coco Best version 2.1.0.h5, MobileNet, Idle Proof Resnet. Okay, so the model, the names, ending with .h5 are basically models. Okay, so you can play with these three models to check which is performing how, and is there any difference between the types of model. And all you need to do is, if you want to use YOLO, you need to do this set model type as tiny YOLO version 3 or YOLO version 3. As of now, I'm using RetinaNet, and the other exercise is left for you all as the assignment for today. Okay. So I told my detector object that I will be using model RetinaNet for the object detection. Okay. Now I need to specify the weights of the object. Okay. So this is the most important step, that right now basically this detector only knows that I will be performing retina net. I will be performing object detection using retina net. Okay, now I'll be providing the weights of the model. Okay, so weights of the model are very much important. Okay, so just copy the path from here, copy path, and paste it over here. Okay, so basically our model is also loaded. Now what we need to do is we need to do this to load the actual model we will be using. Okay, so detector.load model will load the model for object detection. Okay, and it's taking a while to load the model. Okay, now I need an image. Okay, so basically I will be using an image from, so let's just me use a traffic image. Okay, I'll be using this traffic image. Let's just go and check out some. Okay. Let me just go search image. Um, so let's use this image. Okay, so I'm using this image and I'm saving it downloads, saved. Now coming back to Colab, I will be uploading this image which I just downloaded. Just upload the image. Okay, Tanishka is getting an error. So Tanishka and Raval both are getting an error. So what is the error? Like, can you type in the comment section? I will be helping you all out. Just let me know what the error is. Okay, and meanwhile, now we'll be performing the object detection. Okay, so now what we need to do is we need to use detector. Okay, so detector was the name we used to create object of for object detection, and what we need to do is detector dot detect objects from image, and where the input image is the one which we downloaded just now, and okay, that's not the actual format. I just ran it by mistake. Okay, and then there is this thing. Okay, so I need to provide output image. Okay, image path, and that is basically the output image path is basically my this folder. Okay, so this folder in Colab is known as content. Okay, so I will be using this, and I will be providing the name of the image. Okay, so object detection dot jpg. Now if I execute this command, okay, so let's check that using pillow library that how our object detection model performed or whether it worked or not. Okay, pil dot image dot open, and just let me, okay, just let me, okay, sorry, I opened the wrong image. Okay, so this is the image of the actual, and this object detection value error. You must set a valid model type before loading the model. Okay, so there's a problem with your this. Oh, Tanishka, yeah. So Tanishka, you have problem with this set model path. Okay, so I think you have not provided the path correctly. Okay, so if you don't provide the path correctly, here you will get the error while using this detector.load model, and it will give you error that you must set a valid model type before loading the model. Okay, so just check this path. Okay, so this is our actual image, and this is the image where the object detection has been performed. Okay, so you can see that our object detection model actually identified that this is a car, and due to the background, the bounding boxes are not much visible, but actually there are bounding boxes. You can see that this whole car has been enclosed in a bounding box, and the probability percent is 52.03%. And this car is basically as also enclosed in the bounding box as well as this car. This car is 93%. The model is 93% sure that this is an image of object, car object, and same for this, but with 94%. Okay. So let me just use a real world image. Like I was not getting the real world image. Okay, so just let me use this. So let me just search for park images. Okay, so I think this image should work. So save this image, load this image, and change this to this park PNG. Okay. So now we have a new image, and let's check that how a model performs on this image. And let me just delete this object detection. So this is our image, and just let me delete this cell because it's of no use. So as you can all can see that our object detection model actually identified different person, and it identified frisbee, sports ball, and this whole, what is this calling, umbrella. Yep, this is an umbrella shed. So our object detection model detected this is an umbrella shed, and these are the different person, sports ball, frisbee. Okay, so this is how actually object detection output is. Okay, so you can use different types of model. For example, here I used retina net. Okay, so instead of retina net here you can use YOLO. Okay, all you need to do is change this to YOLO. Okay, so that was all for the session, and I will be providing you assignments in the Discord group, so make sure you join the assignment, the Discord group, and get the assignment, and I will be sharing this PPT as well as this Colab notebook. So if anyone has any doubts, they can ask in the comment section, or if anyone doesn't have any doubts, then yep, we are good to go. So just let me know in the comment section that everyone got the concept, or anyone is facing any error, or anyone has any doubts. Just let me know in the chat section. Okay, so I think that pretty much everyone got the concept of object detection and how to perform object detection using image AI library. So when you all will be proceeding towards a more advanced workshop, you will be all getting to know that how this object detection was actually performed using RetinaNet, and what is the meaning of these weights, and what is TensorFlow, and how to perform object detection from scratch, how to train your own YOLO model or any other object detection algorithm, how to perform image segmentation using fast RCNN, fast CNN, and okay, so yep. Okay, Pratyush has a question. What are different models that we should try? You can try there's a whole library, like a whole platform known as Detectron True. You can go and check it out, and in the documentation, it's pretty much written in a very crisp and very elaborative way. So you can check out Detectron True, Detectron 2, and you can check out YOLO version 5, version 4, version 3. You can use fast RCNN, faster RCNN. Okay, so okay, it was a great session, and you all can follow me on LinkedIn, GitHub, as well as Kaggle, and connect me over there. If you have any doubts related to your assignments or related to anything in computer vision, machine learning, or deep learning, you all can just connect me with there, and I will help you out. Okay. So yeah, thank you everyone. Thank you for attending the session, and make sure when we as a Floxus come up with a more advanced session, you all enroll and go through it. Okay. Okay. Goodbye. Good evening.